Hi everyone, I'm Les.
And I'm Ashley.
And you're listening to Anthropotamus, where we explore some of your favorite anthropology topics.
Hi everyone, welcome to our latest episode of Anthropotamus. For those of you who are listening, we are doing video today, so if you want to check out our beautiful faces, we're on YouTube now. Today we're here with Elena Essel from the Max Planck Institute of Evolutionary Anthropology in Germany, located in Germany. We're discussing her article, which she worked on with various other colleagues, titled Ancient Human DNA Recovered from a Paleolithic Pendant. Some of you may already seen many articles on this with some great photos. Thank you, Elena, for joining us on the show today.
Thank you for having me and being excited about this project as well.
So before we get into the article, tell our listeners a bit about your background, what led you to pursue career in archaeology and genetics.
Yeah, so I actually studied biology and I ended up in Leipzig kind of coincidentally, and then learned about the Max Planck Institute for Evolutionary Anthropology. And I started as a student assistant here. And I was really like a lab rat helping out with some of the lab work and got really fascinated by the possibilities that are already there to look into our history or into human history using the tools of ancient DNA. And I was really mind blown by the possibility that we can sequence Neanderthal genomes and Denisovans genomes and ancient modern human genomes. And then I was really stuck then by the methodological advances that were possible made in this lab here. And I really got into methods development then and into the biochemistry behind it. And that's how I started at the MPI in Leipzig.
So going into the article, so we have this pendant, you extract the DNA. So can you tell our listeners, what is the difference between destructive and non-destructive DNA analysis?
Mm-hmm. So what we usually do when we work with bone or tooth samples from like fossil record is that we drill a really little hole into the bone or tooth sample. So we're using a dentist drill. So it's usually only a few millimeters in diameter, but we still need to drill a little hole to collect bone material. This is destructive, and for some samples, it's just not possible to do destructive sampling. And one type of samples are these precious artifacts. We cannot do destructive sampling on them because they preserve extremely valuable information on the surface. So, for example, experts can look into the surface structure and learn about how these artifacts were made or how they were used. And so really the main goal for this project was that we preserve the surface structure. And so we wanted to avoid this drilling process. And so instead, we developed a strategy where we submerged the whole sample into a buffer. We ensured that this buffer is not causing any damage to the surface structure, and extract DNA then by the submerging and buffer instead of doing this drilling approach.
So to be able to collect enough DNA, is this something that someone would have to be constantly holding or wearing for a long period of time, or is it possible that it just happened to be the last person to hold it? And then is it possible to then identify possibly more than one person who had handled it?
So for the first part of your question, the unsatisfying answer is we don't know how long a person has to handle an object to leave enough DNA on the sample to preserve it over thousands of years. Mm-hmm. It's also a bit hard to investigate this or to do technical tests on this because the simple fact that this thing is 20,000 years old, we cannot mimic. We cannot use a fresh sample and wear it for a year and see how much we get, because we cannot mimic these 20,000 years. Our hypothesis though is that an object needs to be handled intensely to leave enough DNA and to allow the penetration of the DNA deeply into the matrix of the bone or the tooth. But yeah, unsatisfyingly, we cannot tell how long this needs to be handled or how much direct contact we need to be able to recover the DNA after thousands of years. For the second part of your question, if we are able to detect if it's more than one person who handled an object, So in the case of the Denisovan tooth pendant that we were able to extract ancient human DNA, we actually found at least two individuals, DNA of two individuals. And it was super interesting because it was 90% coming from one individual. And this is also the DNA that we were able to look closer into and identify the sex and look into the population genetics. And then we have another proportion, roughly 10%, where we don't have so much data and like cannot look as deep into the history or into the specifics of the DNA. So yes, we do see that we have two different types of DNA. It's a bit tricky to say it is one or two individuals. It could also be more than that, but we have at least like a minimum number of two individuals detected here. It's a bit hard to foresee how it will be in future samples. So we hope to be able to reproduce this result. We can extract DNA also from other artifacts. And I hope that we can learn about, or we can learn more about this distribution of DNA if it's coming from one or more individuals in the future.
Les, do you have any questions so far?
Yeah, so you know what, I'm not sure if I missed it in the article. This was recovered from, can you tell me about a little bit about the site this was actually recovered from?
So it's coming from Denisova Cave. It's a cave site located in Siberia. It is mostly famous for the discovery of the Denisovans. So it's like a cousin group to the Neanderthals. It's another ancient hominin group. We also know that Neanderthals lived there, and we know that modern humans lived there. And more recently, I think it was like also pretty big in the media. There was the discovery of the first hybrid sample that we know so far. So this bone had like a Neanderthal and Denisovan component. So like it's like a hybrid between Neanderthal and Denisovan. So it's really like a bit of a treasure trove for ancient DNA research.
Okay.
So like DNA preservation is extraordinarily good there. It's like close to the Arctic Circle, so it's really cold, stably cold there, which is awesome for DNA preservation. And it seems to be occupied for quite a long time. So we have many findings there in terms of faunal remains, hominin remains, and also artifacts.
Okay. So you said we found hominin remains there. I'm assuming this was a dwelling and not any kind of grave good. So
yeah.
this would be just an item that was in the dwelling. It was not near any of the human or hominin remains?
I mean, there are also hominin remains found in the same layer, but in this time frame that we are looking at, burials are really rare. So it's a bit unclear, or at least, I mean, I already told Ashley, I'm not an expert in anthropology.
I see.
So I'm not sure how common burials would be in that time frame, but if they are common, or how to phrase this, they might be common, but they are not preserved because we are looking into 20,000-year-old samples. So there's too much of degradation happening. So I'm not sure if you would be able to even identify a burial as such for such a long time.
Yeah.
But in this case, like we don't have a burial context for this pendant.
Okay. Yeah.
Yeah. To answer your short.
Yeah.
Sorry.
No. A little bit of context is always appreciated. Gosh, I mean, so you already explained how it works, but were you guys the first ones to use this method of sampling for the DNA to extract the DNA?
So the method itself was used for other applications in ancient DNA work. It was actually developed to do pre-treatment of the bone powder that is collected with this drilling method to reduce the contamination. So this was the initial application for this method. And when we then started exploring potential non-destructive extraction techniques for the artifacts, it was one of the methods we looked like closer into, and it was the only one where we were able to extract DNA without causing damage to the surface structure of the artifacts.
Right.
So you mentioned in the article that to prevent contamination, you use gloves and masks. Is this a procedure that you feel may be used further in archaeology to prevent contamination?
I mean, also there, I'm not an archaeologist, I'm a molecular biologist. So, and I can't, and I don't want to tell my colleagues in archaeology, like, I don't want to tell them how to do that job. So it's a bit tricky, like thinking about excavations, it's really hard to wear all this protection gear because it's already physically challenging. It's like in some cases you have like extreme temperature, so it's already super warm and you don't want to wear gloves all the time and face masks all the time. So I think it's a matter of finding the best solution for preserving or limiting the introduction of modern contamination, but still making the work feasible for the archaeologists. So I think a good compromise could be that as soon as you start seeing during excavating that this is an artifact and this is something you would be interested in doing DNA extraction on, then putting on gloves, put it directly into a sterile bag and put it aside. In the ideal case, of course, we would be super happy if people are excavating with gloves and face masks, but we do understand that this is not always possible. And so I think it's a case-to-case decision or case-to-case. One has to evaluate what is possible in the actual field work.
So are there any plans in the near future for another excavation and another testing of DNA for any possible artifacts that will be found?
Yeah, also this is nothing I can decide. So we actively reached out to, like, we have a number of collaborators we are closely working with who are actively excavating this season, and we reached out to our collaborators and we're like, hey, we have this method now. If you are interested in applying it to some of your samples, then let us know. Here are the things that we recommend for excavating those artifacts. If you have something that fits this criteria, get in touch with us. And also, like, people are now contacting us that we haven't been working with, like expressing interest in applying the method to material that they have excavated recently or are like going back to excavations this season. And yeah, hopefully we get some more fresh material we can apply this method to, and hopefully be able to replicate these results.
Yeah, that would definitely be interesting to see what else we can apply that to. There's so many different samples and other artifacts that we've discovered that we just never were able to do any kind of DNA testing on, or DNA testing on. That's exciting. That's very exciting.
It is, and like I'm especially hoping for like, quite often the questions are actually brought to us by the archaeologists. So as I said repeatedly, I'm not at all into anthropology. I'm really like a hardcore methods person. So I quite often don't even know what are, like, in a specific site, sometimes I don't even know the site. So like, archaeologists approach us and they come with a question. And I think this is actually a cool way to collaborate on those things, because like the expertise in anthropology is there from the team of archaeologists, and we can kind of plug in some of the techniques that we developed in molecular biology to help answering questions, or at least try to help answering questions that our collaborators and our colleagues have. And I'm kind of hoping for one of these collaborators reaching out, working on one of the transitional layers where it's currently unclear if artifacts were made by Neanderthals or modern humans. So this would really be, like, if I can wish for a set of samples that we can work on, I think this would be super, super exciting to contribute like some insights to this big question that is lingering around in the field for decades.
Yeah.
Yeah, sure.
It'll definitely be nice to have some actual, biology sprinkled into our anthropology. Not that we have zero,
No,
but
definitely not. Definitely.
A professional anthropologist is very different from a professional biologist, and you guys have definitely a lot to offer that we can well, I expect the collaborative effort is going to yield positive results.
I hope so. And I mean, it's really a, like, how do you say, like an equal relationship. So I cannot do anything with the DNA results because, like, even if it's like the most exciting results in the world, I would not understand, and I could not like make the associations with stratigraphy and with all the other finds that like archaeologists were working on for decades on the site. They know each and every artifact that was excavated there. They know the chronology by heart, and only then, like with the combination of those two tools, we can, like, this method is useful. It's like this method doesn't bring anything if we don't have anthropologists to actually interpret the data. I can only say there's ancient DNA, and I can say it's coming from female or male individual. Maybe I can tell how old it is, but that's really what I can do. That's where my expertise ends, and we really need then the anthropologists to make sense of what we find. Otherwise, we would be lost.
Well, I don't have the context of the site to draw on here, but I can say that even that much data being added into it would tell anybody who's excavating it. I mean, that's a ton of context right there. You had two individuals, male and female. Well, based on what else in the site, what else can we tell from that, right?
Yeah.
Super exciting, super exciting.
Well, thank you, Elena, again for coming on the show with us. To our listeners, visit us at anthropotamus.com. You can purchase some of our merch. 60% of profits from our merchandise will go towards STEM scholarships. Find us on iTunes, Audible, Apple Podcasts, CastBox. We're everywhere. And until next time, bye. Thank you all for listening. Please continue to follow us on Twitter and Instagram at Anthropotamus for our latest episodes, show notes, and book discussion schedule.